Let's start our discussion now. Neeraj, Sarath.
Yeah.
Okay, sir.
Okay. Now we can focus on our next book. It's a VPN concept.
Sir, well, 1 minute, one question.
Yes, Neeraj.
Sir, are we, did we leave anything on FTD/ASA from training perspective?
VPN concept, VPN video I will share with you. Only VPN topic.
Sir, VPN is important. अगर आप वो लैब में करके दिखा देते तो अच्छा होता.
Sure, no problem, Neeraj.
If not today,
Policy based and route based, I will show you in next session. No problem.
Yeah, policy based and route based both. Yeah.
No problem.
Thank you.
No problem. Okay, now let's focus on our router-based VPN concepts. So these are the topics. These are the VPN implementation. We can discuss now. What about basic VPN, everyone? Neeraj, have you finished basic VPN concept?
Yes, sir.
Okay. Sarath, let's revise first, okay?
Yeah, sure.
Basic VPN concept first. After that, we can
Sir,
focus
sir,
on these.
I could not practice because I could not get into the lab.
No problem. No problem. Okay, so if you talk about VPN implementation, our focus is on site-to-site VPN topic, site-to-site. We are connecting multiple branch offices now. So for site-to-site, we can go with IPsec implementation. IPsec we are using for site to site VPN connectivity. So if you have two branch office A and branch office B, if you are connecting these two branch office over this public network in a secure manner, so you can establish your VPN tunnel. You can establish your VPN tunnel in between site A and site B. This is what IPsec site-to-site VPN tunnel, branch to branch connectivity, or you can say LAN to LAN connectivity. For site to site, you can go with IPsec option. If you talk about IPsec, so in IPsec, we have multiple protocols. They can work together to provide you secure VPN connection. If you talk about IPsec complete configuration, so complete configuration is divided into two phases. Complete configuration is divided into two phases. It's called IPsec phase 1 and IPsec phase 2. What we can do in IPsec phase 1? Neeraj, any idea?
Sir, from theory standpoint, this one IPsec phase 1 and phase 2.
Yes. What we can do in phase 1? In phase 1 we can generate session key. Sarath, remember basic VPN?
Yeah, we will exchange the session key.
First, we can generate what? Session key, right? So we have two branch office A and branch office B. So what we are doing, we are generating session key. And to generate the session key, we are using a mechanism in background. It's called Diffie-Hellman mechanism. So we can generate, my point is we can generate session key on both branch office. For example, I am using session key CCNA. Session key I'm using on both branch office. What is the next step? Next step is to exchange the session key. Exchange session key. And to exchange session key, we need to set up our first tunnel, or you can say phase 1 tunnel. So in phase 1 configuration, we are not exchanging any data traffic. In phase 1 tunnel, what we are doing, we are trying to exchange our session key, right? We are trying to exchange our session key. It means We are trying to establish a bridge first in between site A and site B. Once bridge will establish, then yes, we can send our data traffic or LAN traffic. So in phase one, we are trying to exchange session key only. And to exchange session key in between branch office A and branch office B, we can set up our first tunnel, or you can say phase one tunnel. To create our phase one tunnel, we need parameters. We need parameters for encryption, for hashing, and authentication key. Authentication key. For encryption, you can go with DES. DES will provide you 56-bit of encryption. DES will provide you 56-bit of encryption. You can go with higher bit option, triple DES, for example, triple DES. And if you want to go with higher bit, so you can go with IS option. AES. AES is what? Advanced Encryption Standard. AES is a popular option. Why? Because we have variation in key size in AES, like AES 128, AES 192, AES 256. So we have variation in encryption. You can go with DES, triple DES, or AES. Hashing we are using. For hashing, we have two options, MD5 and SHA. SHA is a popular option. Why? Because we have a bit size. We have variation in bit size. SHA is what? Secure hashing algorithm. So in SHA, we have SHA-1, SHA-256, SHA-384, SHA-512. What about authentication key? So for authentication key, we have a method is called PSK, pre-shared key. PSK is a method only, everyone. It's a method. PSK, pre-shared key. It means we are using same key on both branch office. Same key, same session key on both branch office. Phase one protocol on router. On router, phase one protocol is, or you can say tunnel protocol is ISAKmp. ISAKmp is a protocol if you are configuring VPN on router. ISAKmp works with UDP port number 500. So this is our phase one configuration. So in phase one, we are not exchanging any data traffic. In phase one, we can establish our bridge first in between site A and site B. Once bridge will establish, and if there is no any issue in phase one configuration, then you can go with phase two. You can establish your phase two tunnel. Through phase two tunnel, we are exchanging our data traffic or LAN traffic, you can say. So to create our phase two tunnel, this is our phase two tunnel. To create our phase two tunnel, we need two parameters. We need encryption and hash. Encryption and hash. For phase two protocol is what? ESP, encapsulating security payload. It's a protocol. So phase one protocol is ISAKmp on router. If you configure a phase one on any firewall device, this is called IKE. Sarath, it's a IKE, Internet Key Exchange. It's the same. On router, you can say ISAKmp. On firewall, on any firewall device, you can say IKE. Phase two protocol is ESP. Clear my point, everyone? Phase
Yes,
one and phase two. So our focus is on router based VPN. Okay, this is our next book in our security training. These are what? Router based VPN. These VPNs you can configure on router. On firewall, we are only configuring IPsec VPN. But these are the popular VPN option you can configure on any high-end router, on any Cisco router. So the first lab is what? LAN to LAN VPN. This is our first lab. LAN to LAN. Or you can say site-to-site VPN implementation with CryptoMap. CryptoMap. Any idea about CryptoMap? Any idea about CryptoMap? Let's create a topology first. Neeraj, Sarath. Let's create a topology for our first lab. It's a site-to-site VPN on Cisco router. Give me 2 minutes, okay? Wait. Let's create a topology. Into this topology, we are connecting only two branch office. Only two branch office. Branch office A and branch office B. R2 we are using as a ISP router. So this is site A branch office. Site A. This is site B. And this router R2 we are using as a ISP. ISP router in between R1 and R2. In between R1 and R2, I'm using 10.1.12.0 network. For LAN side network, we can create loopback on both branch office. So I'm creating 192.1.1 loopback and 3.3.3/32. So we have a loopback for LAN traffic. Let's configure basic stuff, everyone. Neeraj, Sarath.
Okay, sir.
Basic stuff means what? IP address configuration and default route towards ISP. So what I'm doing, I'm configuring IP address on site A branch office, IP address on site B branch office, and we can configure default route towards ISP. Into this topology, this R2 we are using as a ISP router. This is what? ISP router. Why? To create a reachability, to create a reachability in between site A and site B. To create a reachability in between site A and site B, this portion. I'm talking about this portion, reachability. This source public IP to this destination public IP. This is public facing interface. Neeraj, please turn off your mic.
Okay, sir.
Okay, so let's start our basic configuration. So this is R1 router. You can configure host name here for identification. So this is host name site A. Site A. So interface fast Ethernet 0/0, 10.1.12.1, 255, 255, no shutdown. We can create a loopback interface. I'm using /32. Show IP interface brief. Let's move on. ISP router, R2 into this topology. R2 we are using as a ISP router, so we can configure interfaces only. 10.1.12.2 mask, no shutdown. 0/1, 10.1.23.1 mask, no shutdown. Show IP interface brief. Let's go to R3. This is site B branch office into this topology. R3 host name site B 0/1 interface 0/1 interface 10.1.23.2 no shutdown. And for LAN traffic we are creating loopback here. So 3.3.3.3/32. Now let's configure default route. So from site A branch office, I'm creating default route towards ISP. So for any network, any mask, 10.1.12. Next hop IP. And on site B, any network, any mask, 10.1.23.1. It's the next hop IP. So it's a real branch office. Needed Sarat. Okay, I have a branch office. My point is I have a branch office with LAN interface, WAN interface, and default route towards ISP.
Okay, sir.
You can verify now from site A branch office. You can verify now you have a connectivity with public IP. If I'm trying to verify my connectivity with 10.1.23.2, from here, I'm trying to verify my connectivity with 23.2. So you can see here we have public to public IP connectivity. We have public to public IP. See, I'm getting reply. We have public to public IP connectivity. Only. Neeraj, Sarath.
Yes, sir, I got it.
Sarath, can you
Yes,
hear
sir.
me? Now we can try to establish our VPN, and this is our first lab. In router-based VPN, this is our first lab. You can say crypto map. Okay, let's go for the configuration. So this is site A branch office. So for VPN configuration on Cisco routers, you can use crypto map command. Crypto map. So first we can go with crypto isakmp. Crypto isakmp key. Now you can define your key information. So I'm creating session key, everyone. I'm creating session key CCNA 123. And this session key I want to exchange with other branch office. Other branch office. So other branch office public IP address is 10.1.23.2. So into this command, you are trying to generate your session key CCNA 123. Same session key I will configure on other branch office, and you can specify this session key we are trying to exchange with this specific public IP 10.1.23.2. So first you can generate your session key. What is the next step? To exchange this session key, we can set up our phase 1 tunnel, right? We can set up our phase 1 tunnel.
Yes, sir.
And for phase 1 tunnel, command is crypto isakmp policy. And if you type question mark, you can get a number. We have a big number to create our phase one tunnel. Big number. You can create approx 10,000 tunnel, phase 1 tunnel. So I'm creating my phase 1 tunnel, first tunnel, for example, into this topology because we have only 2 branch office, site A and site B only. So crypto ISAKmp policy 1. Now here we can define our parameters. Okay, for example, for encryption, yes, you can go with DES, you can go with AES, you can go with triple dash. So I'm using triple dash. For hashing, yes, you can go with MD5 or SHA. So for example, I'm using MD5. For Diffie-Hellman group, so group I'm using, here we have 125 only. But if you are working with any high-end router, so you can get other Diffie-Hellman group information. I'm talking about bit size. Okay, if you go with Diffie-Hellman group 1, so it will provide you 768 bit of encryption. Let me hashing key. Let me check here. Wait. Yes, if you are going with Diffie-Hellman group 1, it will provide you session key size 768. Diffie-Hellman group 2 1024 session key size, and Diffie-Hellman group 5 1536. If you want to go with the higher bit, so no problem, you can go with the higher bit. Let me show you the higher bit option. So yes, we have Diffie-Hellman group. See, 125. Here we have other Diffie-Hellman group, and these are what? Session key size. So you have multiple options for Diffie-Hellman, but into this topology, we are using, for example, I'm using 2. Same parameter I will configure on other branch office. Now you can exit. Oh, wait, authentication key, it's a pre-share. Now you can verify your configuration again, show running configuration. So we complete our session key configuration and phase 1 configuration. So this is what? Session key configuration, and this is phase 1 configuration. What about phase 2? So phase 2 protocol is everyone ESP protocol, right?
Yes.
ESP. So command is crypto IPsec transform set. What is transform set? Set means what? Combination. Set. Combination. So here you can give a name for this combination first. For example, I'm using TS. And now if you type question mark, you can see here we have AH protocol and we have ESP option. AH is what? Authentication header. Okay, you can say authentication header. If you talk about phase 2 protocol, we have two options, AH and ESP. If you go with AH, it will only provide you hashing mechanism. It will not provide you encryption. But if you go with the ESP protocol, you can see ESP will provide you encryption option and ESP will provide you hashing. That's why we are using for phase 2 configuration, we are using ESP protocol, ESP triple dash, ESP MD5. Exit.
Sir, the question here is,
Yes.
how do you decide which one to use?
Your organization can decide, okay, which parameter you want to use. Higher bit, lower bit, Neeraj. Your organization can decide, okay, which parameter we want to use. If you want to go with the higher bit, so this will take time to decrypt and encrypt your information, Neeraj.
Okay.
Okay. So if you go with the higher bit, for example, I want to use AES 256. It's good. It will provide you a strong security, strong encryption method, but it will take time to decrypt information. Okay. So depend upon your traffic and your organization requirement. Okay, which encryption method you want to use or which hashing method you want to use. Clear now? But my point is parameters is available, Neeraj.
Okay, sir.
Parameters
Sir,
available.
can you
Now you can
explain?
decide.
Okay, sir. Can you explain this command once again? Crypto IPsec transform set.
This is
TS is the
this
name.
is phase 2 configuration.
Phase 2 configuration, but
Phase
why
2
do we need to
configuration. In phase 2
What?
configuration, command is what we are creating transform set.
Okay.
This is phase 2 configuration command. Okay, in phase 2, we are creating transform set.
Okay, sir.
In transform set is what?
Are we,
It's a
wh- why are we transforming from one mechanism, one hashing mechanism to another hashing mechanism?
see, no, you can say transform set is what? It's just a name, okay?
Okay.
Transform set is a name for this combination. So I'm creating a combination of encryption and hash for phase
Okay.
2 tunnel configuration. So for
Okay.
this, we have a command set, what? Transform set. To
Okay.
create this bundle, we have a transform set command. And this is
Okay.
transform set name, bundle name.
Okay. And the transformation set information.
It's just a name. It's
should-
just a name. If you talk about
Yeah. Okay.
phase 1,
I
let
get
me
that one, and it should match with the peer,
see.
right?
This
We
is
are creating
phase
tunnel.
1 configuration, Neeraj.
Yeah.
So how you can say that is there any? We haven't defined any name. Something is this is phase 1 or phase 2. You just
Okay.
type what? Crypto ISAKmp policy. This
Okay.
is a command syntax for phase 1, right? This is the
Okay.
command syntax for phase 2. In phase 1, we are creating policy. It means this is phase 1 configuration. ISAKmp policy. And if you go with transform set, it means this is a command syntax for phase 2 tunnel configuration.
Okay.
In phase 2 tunnel, we can create transform set. It's a set means what? Combination. And this is our combination. Encryption and hash.
Okay.
As I,
So
as I s-
combination of encryption and hash
yes,
is transform set.
as I said, in phase 2 tunnel, we
Okay.
need only two parameters, encryption and hash.
Okay.
So
I
this
got it.
combination name is what? Transform set. And what is
Okay.
transform set name is? TS we
TS.
are using.
Yeah. It can be
On
anything.
other branch office, you can use any other name, no problem.
Yeah. Yeah. But sir, transforms. I mean, the combination should be the same, right?
Yes.
Okay.
Combination and same parameter, I believe. Parameter is it should be the same on other branch office, on both branch
Okay.
office.
Okay. I got it.
Sarath, any question do you have?
No, it is clear for me, sir.
Okay. Now we can decide our interesting traffic. What traffic you want to encrypt, you want to send through your VPN tunnel. So in our topology, let's create we can create one more loop backbeat 192.168.10.1/24, and on R3 I'm creating 192.168.30.1/24. So now let's go to site A branch office. So now my point is we can define interesting traffic. What traffic we want to encrypt in our VPN tunnel. So to encrypt our traffic, to match our traffic in Cisco router, we can create access list to match our traffic. And I'm using number 100. It means what? Neeraj, Sarath, 100 means what?
Extended.
Extended SSL, right?
Excellent.
I'm trying to configure extended. It means it's required source IP and destination IP, right? So
Yeah.
access list, permit, IP, source. So source is 1.1.1.1. If source 1.1.1 trying to communicate with 3.3.3. So I want to define interesting traffic. If source into this ACL, if this
Yeah.
source 1.1.1 is trying to communicate with this particular 3.3.3 IP address, so you can create your interesting traffic, and this interesting traffic we can call in crypto map. So now we configure phase 1, phase 2, interesting traffic. Now we need to map all the configuration with each other. We can map all the configuration with each other. So for mapping, we have a command crypto map. Crypto map. And now you can type question mark. You can give a name for this crypto map. You can give any name here. C map, question mark. You can give a number for this crypto map. So I'm creating my first crypto map. Now command is IPsec ISAKmp. IPsec. So this crypto map is what? IPsec isakmp, and I'm creating my first crypto map. Into this crypto map, when you press enter, you are getting a message. New crypto map will remain disabled. Will remain disabled until a peer and valid access list have been configured. So what I'm saying match, please match address what? 100.
100.
Please match address 100. And in 100, what we have? This source trying to communicate with this destination. So please match 100. And when 100 match, then set peer address 10.1.23. And set transform set. Transform set name is what, everyone?
TS.
TS we are using. Now this crypto map you can apply on public facing interface. Into this topology, fast Ethernet 0/0, it's a public facing interface. So crypto map, and what is crypto map? C map. Press enter. Now we are getting a message. isakmp is on, right, Sarat? isakmp is on. If you type, okay, let's go to other branch office. Let's go to other branch office. And here we can configure VPN with same parameter, Neeraj. Crypto Isaac, okay, crypto isakmp key CCNA 123, right? I think we are using CCNA 123. Now address this session key I want to exchange with 10.1.12.1. This is site A branch office, public facing interface IP address. Now crypto isakmp policy, and I'm creating phase 1. Into this phase 1, I'm using parameters. So for encryption, same parameter I'm using for encryption. We have triple-dash for hashing, MD5 for authentication, pre-share key, Diffie-Hellman group to exit. Phase 2, crypto IPsec transform set, and transform set name is TS. Now ESP triple-dash, ESP MD5. This parameter we are using for phase 2. Same parameter. What about interesting traffic on site B branch office? So now source is 3.3.3 and destination is 1.1.1. So for interesting traffic, we can create ACL, access list 100, permit, IP, post. Source is what, everyone? 3.3.3.3. Destination is 1.1.1. Now we configure phase 1, transform set, interesting traffic. Let's map all the configuration with each other. So for mapping, command is crypto map. So I'm creating crypto map as C map, just a name. Crypto map and one IPsec isakmp. Now match, please match address 100. Then set, if it's match, then set peer address 10.1.12.1 and set transform set as a TS. This crypto map you can apply on public facing interface, crypto map, and crypto map name is C map. Yes, sir.
No.
Clear now? We are getting a message isakmp is on. Now, if you go and check your phase 1 tunnel, show crypto isakmp SHA. Neeraj, this command we are using to verify our phase 1 tunnel. What is SHA? What is SHA, everyone?
Security Association.
Security Association. So crypto isakmp SHA. So with this command, we are trying to verify our phase 1 tunnel. So right now, there is no any tunnel. If you go and check show crypto IPsec SHA, this command we are using to verify our phase 2 tunnel. If you verify your packet information, so 0 packet encrypted, 0 packet decrypted, So now we can try to initiate our traffic, but before initiate our traffic, let's capture, okay, wait. For example, I am attacker, I'm hacker, and I'm trying to capture the packet in between site A and site B branch office. Let's verify what I'm getting, okay? I can capture, for example. So let's initiate our traffic. I'm trying to ping 3.3.3 with source 1.1.1. Neeraj, Sarath,
Yes, sir.
Yes.
let's initiate our traffic, everyone. I'm getting reply. Let's initiate our traffic packet. I'm getting reply, right? Now, if you go and check your phase one tunnel first, Shoro, Crypto, ISakmp. So yes, you have a phase one tunnel in between this source public IP to this destination public IP. State is what? Idle, and QM is what? It's a quick mode. Status of this tunnel is active. If you verify your phase two tunnel on phase one tunnel on site B branch office, show crypto isakmp. Yes, we have a source public IP. Wait. Why we have same configuration? Source public IP it should be. Let's initiate our traffic. Okay, no problem. But here we have source and destination public IP. Let's verify show crypto IPsec. So 9 packet encrypted and 9 packet decrypted. Okay, let's initiate more traffic. So 9 and 5, everyone, 14, right? If you go and check your IPsec, so 9 and 5 is what, everyone? 14 packet. If you initiate more packet, 5 more packets, so 14 and 5, 19. 5 more, 24. So if you go and check, 24 packets. Clear this verification, Neeraj, Sarath?
Yes, sir.
Now,
Yes.
if you go and check on your site A branch office again, so this source and this destination, this source, okay, and this destination can communicate. This traffic is traveling through VPN tunnel.
Yes, sir.
Traveling. Okay, if I'm trying to initiate my traffic, for example, okay, let's create loopback first. Interface loopback 1, 192.168.10.1, 255. Okay, we can create loopback on R3 on site B branch office. Loopback 1, 192.168.30.1. So we have loopback interface. So now if I'm trying to ping 192.168.30.1 with source 192.168.10.1. I'm
We
not
have to
getting
define
reply.
this in the ACL, right?
Sorry, Sarath?
We have to define this in the
Exact-
ACL.
Yes. Thank you. Yes. So I'm not getting reply. Success rate is what? 0%. Why? Because as per our interesting traffic, if 1.1.1 is trying to communicate with this 3.3.3, this traffic is allowed in our VPN configuration. If you guys remember our configuration,
Yeah.
if this traffic is allowed, it's traveling through VPN. So now what we can do, let's create an entry. Access list, yes, 100, permit, and host. So permit IP host 192.168.10.1, trying to communicate with 192.168.30.1. Let's go to site B branch office. site B branch office. So we can create access list 100, format IP host. Here source IP is 30.1 and destination IP is 10.1. Now we can try to initiate our traffic. Let's initiate our traffic now. Sarat, Neeraj,
Yes, sir.
and I'm getting reply now, right? See,
Yes.
this traffic is also traveling through our VPN tunnel. Now let's go to Wireshark. Let's go to Wireshark. And now you can see here. Now you can verify your phase 1 and phase 2 configuration. I'm a attacker, right? I'm a hacker. I'm trying to capture this traffic, for example. I want to verify what information is traveling in between site A and site B. So this is phase 1. This
Sir,
is phase 1.
from where is this traffic being captured?
Right click on cable in GNS3.
Okay, okay. All right, okay. And then you can capture from here. But sir, in real life, how would you capture this traffic?
It's not possible.
Okay,
Neeraj.
yeah. Okay.
As an attacker, you can do, but you have to use other options, okay, to capture a live packet in between site and site B.
Yeah, the only
It's
caption
not
I
simple,
did.
but you can use,
Yeah.
for example, span concept, switch port, and
Yeah,
see.
okay.
Outside
Yeah.
person cannot capture the traffic, but I'm an internal person, for example. Internal person can do. For example, I want to capture packet on this interface. If any traffic will hit on this interface,
Yeah, no, sir, I know the span one. You have to put a laptop and monitor session. Yeah,
yes, you can send your copy of this packet on any other interface.
yeah,
Yes,
okay, I
yes.
got it. Yeah, I thought maybe there is any other way of doing it.
No. Attacker can use tool, okay, but I don't have any idea about these tools, okay. But attacker can capture, okay.
Okay, okay.
So now my point is what when you capture your packet, Sarath, can you hear me, dear?
Yeah.
You can see this is about phase 1 configuration. Why?
Yeah,
Because it's a ISAKmp protocol, right?
yeah,
This is our phase 1 configuration.
got it.
Phase 1. And in phase 1, there are 9 packets. If you go and check here, we have 9 packets. Total 9 packets we have in phase 1. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in phase 1, there are 9 packets will exchange.
Okay.
First 6 packet is called main mode. 6 packet is called what? Main mode. And last 3 packets are what? Quick mode. Quick mode. If you expand your first packet, for example, I want to expand this packet. And if you go and check in detail, so what I'm getting source public IP. You can see source public IP, destination public IP, and protocol ISAKmp, UDP port number 500, right? And this is ISAKmp protocol, full form. Internet Security Association and Key Management Protocol. If you expand this, so you can verify your flag information. In flag, you can see this first packet is not encrypted, Sarath.
Yes.
This first packet is not encrypted. So first 4 packets, okay, 4 packets are not encrypted. These 4 packets are not encrypted. If you check, okay, if you go and check your 4th packet, it's not encrypted. But no problem, okay, they are not exchanging any parameters. Okay, they're not exchanging any parameter in packet number 1, 2, and 3, and 4, Neeraj. Okay, in 4 packet, what they have? Site A branch office. Site A branch office is sending Site B branch office. Hello, are you available? Site B is giving you a response. This is second packet. Then site B is sending a packet, blank packet. Hello, are you available? Then site A is giving response. So this is 1, 2, 3, and 4. Neeraj, Sarath. So
Yes.
in first 4 packet, they are not exchanging any data traffic. They are sending a blank packet to verify other branch office is ready or not, or available or not. Sarath. But if you go and check your fifth packet, so fifth packet is what? Encrypted. You can see. Clear now, Neeraj, Sarath?
Clear,
Fifth packet is encrypted. And if you go and check other information, see ESP protocol, ESP protocol, ESP protocol. Let's initiate a new packet. Okay, I'm trying to ping, for example. I'm trying to ping. I'm sending what? Data traffic. I'm trying to ping, for example, 3.3.t, trying to communicate with 1. So I'm getting some information here. ESP protocol. ESP is what? It's a phase 1. Sorry, it's a phase 2, right? It's a phase 2 protocol. If you expand any protocol, you can see as a hacker, you are not getting anything. See, you are only getting what? Source public IP information, destination public IP information, and ESP protocol. That's it, Sarath.
Yes.
You don't have 1.1.1 information and 3.3.3 information. What is the packet format? Packet format is what? Here you have source public IP, right? 10.1.12.23.2. Destination public IP 10.1.12.1. So attacker can verify source public IP and destination public IP because it's available publicly, right? So he can get public IP information. Then ESP protocol, encapsulating security payload. So ESP protocol, and after ESP we have a traffic. We have a traffic 1.1.1.1 trying to communicate with 3.3.3. So after ESP, everything is encrypted. Attacker can get only this information. Clear my point now, Neeraj, Sarath?
Yes, sir.
This is what our first lab, site-to-site VPN. Site-to-site VPN with crypto map. Can we take a break for 10 minutes, then we can continue?
Yes, sir.
Our next VPN, everyone. Sarath,
Yes, sir.
Neeraj, please turn off
Yes,
your
sir.
mic. We can continue at 10 a.m. Okay?
Okay,
Please
sir.
turn off your mic. Everyone, can you hear me? Neeraj, Sarath.
Yes, sir.
Okay, let's continue our topic now. Neeraj, can you hear me now?
Yes, sir.
Okay. So this is what site-to-site VPN implementation with crypto map concept. Into the scenario, we have a issue. We have a issue with interesting traffic. We have a issue with interesting traffic. My point is, if we have multiple network in LAN side network, for example, I have 50 network this side, 50 network this side, and I want to 50 networks, and I want to send all these traffic through this VPN tunnel. So I need to create each source and destination entry in ACL configuration. Sarath, right?
Yeah, but we can define the network, right, instead of host.
Sorry,
Now, actually, in this ACL, we define the host. Instead of that one, we can define the network, right?
we can define the cost.
No, no, no. Now we define only the host, right? Means loopback 1/1/1.
You can define host or you can define complete network, no problem.
Network,
Okay.
yeah. But each entry we have to, right?
But my point is what? If you have multiple subnets, multiple
Mhm,
network or multiple specific IP address, okay, or
mhm,
and you want to allow everyone to access other branch office network, so you need to define your source and destination information in each ACL entry. Neeraj,
mhm, mhm.
okay. If you have, for example, 100 network this side, okay, 100 network this side. So you need to create 100 net, and in each entry, you can define your source information and destination information. Okay. I cannot allow everyone to access. I cannot use any source, any destination, right? I need to
Mhm.
specify interesting traffic. So this particular source is trying to communicate with particular destination. You can see into this small topology, into this small topology. If this 1.1.1 is trying to communicate with 192.168.30, cannot communicate, Sarath.
Mm, okay.
So for this, what I can do, I can create a ACL entry, right?
Yes.
So so this is the issue. What we need to create ACL entry for each interesting traffic. If we have multiple network, we need to create ACL entry. That is the issue with crypto map. That's why we are using next tunnel option. It's called GRE tunnel. Any idea about GRE tunnel? Sarath, Neeraj, any idea about GRE tunnel, everyone?
Yes, sir.
GRE tunnel? GRE tunnel we are using for Sarath, for site-to-site connectivity. For site-to-site
Yes.
connectivity or for site to multi-site connectivity. So here GRE is what? Only GRE for point-to-point connectivity. MGRE, multi-point GRE. We can discuss later, but let's focus on GRE first. GRE we are using. GRE is a tunnel option. GRE is a tunnel option. We can create GRE tunnel on Cisco router, but GRE tunnel will not provide you encryption. GRE tunnel will not provide you encryption. That's why we can add IPsec, IPsec with GRE. So you can say GRE with IPsec site-to-site VPN connection. Neeraj, clear my point, Sarath?
Yes.
So with why we are doing a lab with GRE? Wait, let's configure first IP address. Give me 5 minutes. I'm doing basic configuration again. Basic configuration again. This is site A branch office, fast Ethernet 0/0, 10.1.12.1. Give me 5 minutes. I'm doing basic configuration again. 1.1.1.1 loop back. Let's create one more loop back. Default route towards ISP gateway for public to public IP connectivity. For any unknown destination, 23.1 is a gateway. So we have public to public IP connectivity or reachability, you can say. 10.1.23.2 I can pick, but we don't have reachability in between LAN to LAN network. I can ping to public IP only, but if you verify your connectivity with 3.3.3, for example, with source 1.1.1, so we don't have reachability in between LAN to LAN traffic. So we can create our secure tunnel, and through this tunnel, we can send our LAN traffic. Neeraj, Sarath, everyone clear my point? So I'm not doing next lab with crypto map. I'm not doing site-to-site VPN lab with crypto map, because in crypto map, we need to define interesting traffic. So I don't want to define interesting traffic. So we can go with GRE. We can go with GRE tunnel. So I'm creating a GRE tunnel. Sarath, any idea about GRE tunnel? Sarath, Neeraj, any idea about GRE tunnel, everyone? It's a routing switching concept. GRE tunnel, it's a routing and switching concept. What is command syntax? Can anyone help me? Interface tunnel, right? Interface tunnel. So we can create our GRE tunnel, and I'm providing IP address 192.168.50.network. 50.network for this tunnel IP. This is what tunnel IP. So we can use a command interface tunnel. If you type question mark, you can see you have big number. You have big number. You can create a lots of tunnel interface. So I'm creating a one interface. It's just a number like fast Ethernet 0/1, fast Ethernet 0/0. It's just a number. On other branch office, you can use any interface tunnel number, no problem. Now into this tunnel, you can specify tunnel source. So to create this tunnel, yes, I have two information, source public IP and destination public IP. To create our GRE tunnel, we need two information, source public IP and destination public IP. So this tunnel into this tunnel, source public IP is 12.1 and tunnel destination IP is 10.1.23.2. Now you can provide IP address for this tunnel. 192.168.50.network, 50.1, mask. Done. Exit. Done. GRE tunnel configuration. tunnel source, tunnel destination. Now you can verify now, show IP interface brief. So you have your tunnel interface. Let's go to other branch office. Other branch office. So interface tunnel 2, tunnel source 10.1.23.2, tunnel destination here 10.1.12.1, and IP address 192.168.50.2. You can use any IP address. This is your tunnel. This is your virtual tunnel. So you can configure any. Yes, Neeraj.
Sir, I think to send the traffic, I think you will have to define a static route, next hop with the tunnel interface of the other side, right? If I'm not mistaken.
See, you can use any routing method, Neeraj.
Okay.
Okay, you are talking about only static. You can configure any routing method in tunnel.
Yeah. Okay.
Let's create tunnel first, okay? Then you can decide.
Okay.
If you want to create static route, no problem. Otherwise, we can use RIP, EIGRP, and OSPF. So now, if you go and check show IP interface brief, here we have tunnel. Sarath, dear,
Yes.
clear my point?
Yes, sir.
Now, if I'm trying to verify my connectivity with tunnel IP, and I'm getting reply. See, ping 192.168.50.2. It's a tunnel IP address on other branch office. And if you verify tunnel interface, show interface tunnel number is 1. Okay, so yes, we have a tunnel. This is tunnel interface. Tunnel is up. And wait. Tunnel status.
Sir, how are we able to ping the other side, the private IP address? Is there any routing protocol running underneath?
See, through this tunnel, through tunnel, yes, I can ping. See, my point is here we have.
Oh, okay. So we have already created
source
tunnel.
public
Yeah.
IP and destination public IP.
Yeah.
On
Okay.
router, we can create GRE tunnel. And to
Mhm.
create this tunnel, we have what? Source public IP and destination public IP.
Yeah. Okay.
So behalf
Okay,
of the source and destination public IP, you can communicate with your tunnel IP. Clear?
Yes, sir. I got it. Sir,
Now,
but still, LAN side will not be able to talk to the LAN side,
no,
right?
they cannot communicate with each other.
Yeah.
Right now, there's no communication.
Yeah.
You have a communication with your public IP, source and destination public IP, and only tunnel IP.
Yeah.
Now, what we can do for reachability, I can configure any routing method. Any routing method. For example, I'm using EIGRP, for example, router EIGRP. EIGRP is a faster protocol, so let's use EIGRP, for example. Now, network. In network, we can advertise tunnel IP, wildcard mask, then network, LAN network, 192.168.10.0 wildcard mask, then no auto summary. Let's go to other branch office. So now you have your tunnel interface. It's like you have a direct cable. You have a direct cable to this other branch office. Clear my point?
Yes, sir.
You have a direct cable, sir. Neeraj.
Yeah,
Direct
I
cable.
got it.
Just like a logical direct cable. So now you can configure any routing method. You have a connectivity with R1 to R3. So now I can use any routing method. For example, router EIGRP 10, 3.3.3.3, wildcard mask, 192.168.30.0 wildcard mask, and network. Our tunnel IP we can advertise here. So 50.0 wildcard mask, no auto summary. You can see now we are getting agencies, right? See,
Yeah.
we are getting EIGRP information. If you go and check show IP EIGRP neighbor, so yes, you have neighbor.
Yeah.
Your tunnel IP is your neighbor. And you can also verify your routes.
Yeah.
You can also verify you have a routes. You are receiving complete routes.
Yeah,
You
we are
are
receiving.
receiving your routes. And if you want to ping, for example, 3.3.3, with any source
Sir,
IP, with any
yeah,
10.1. They all are communicating with each other. And this is GRE tunnel. If you capture your packet, this is GRE tunnel. GRE will not provide you encryption. It's a tunnel, but it will not provide you encryption. Neeraj, Sarath,
Yes.
yeah, sir. We have to create GRE over IPsec, right?
wait. Yes. Let me capture this packet.
Yeah.
So if you initiate your traffic, for example, I'm trying to ping 3.3.3. So traffic is traveling. And you can see as attacker, I can get all the information. See, 10.1 is trying to communicate with 3.3.3. Sarath.
Yes.
Yeah.
So if anyone captured the packet in between site A and site B branch office, they can verify what traffic is traveling in between site A and site B.
Yeah.
So see, ISMP protocol header, you are getting source and destination IP, source and destination public IP, GRE,
Yes, sir.
generic routing encapsulation, GRE. So GRE will not provide you encryption.
It will provide only encapsulation.
Connectivity, yes. Encapsulation, connectivity, yes. Encapsulation, connectivity. It will not provide you encryption. That's why what we are doing, we are trying to attach GRE. We are trying to add GRE with, we are going with GRE with IPsec. How to configure IPsec? Let's create IPsec config. It's the same step. Crypto, ISAKmp, key, CCNA 123. Address. Give me 2 minutes.
So this lab is functional now?
Yes, I will provide you rack access. Okay.
Okay.
Okay, now let's focus on here. So we can create, 10 dot. So now crypto ISAKmp, I want to exchange this session key with 23.2. Crypto ISAKmp policy 1, authentication pre-share, Diffie Hellman group 2, encryption, triple dash, hashing MD5. Crypto IPsec transform set TS ESP, triple dash ESP MD5. Now I'm not configuring interesting traffic. Now I'm not configuring interesting traffic. If there is a connectivity in between site A branch office, site B branch office, they all are communicating. Now I can encrypt this traffic. I'm not
Sir, you
defining
will not
interesting
create
traffic.
you will not create even a crypto map?
Sorry?
Crypto map.
Crypto map I will create, but my point is here. In internal configuration, Neeraj, we can create IPsec profile. We are not creating crypto map. Yes.
Okay.
This is not a crypto map lab. Okay. Whenever you are working with tunnel interface, you can create IPsec profile here. Sarath,
Okay.
Yes.
command is
Yes, sir.
crypto map IPsec profile. So I'm not creating crypto map. Why? Because this is not a crypto map lab.
Okay.
And I'm not defining any interesting traffic. After phase 2 tunnel configuration, I'm creating crypto map, IPsec profile. Profile name, you can give any name, prof1, for example, prof1. Now here we can call only set transform set TS. And this profile, this IPsec profile, you can apply on tunnel
The
interface.
Okay.
And how to apply this profile on tunnel interface? Tunnel protection IPsec profile, and profile name is prof1. Done. You can see ISAKmp is on. So we are getting some message now because IPsec is not configured on other branch office. Before configure IPsec on other branch office, let's go to tunnel. Okay, wait. Let's configure first on side B branch office. So I can copy this configuration. Wait. Now I can apply this on tunnel interface, tunnel 2. Tunnel protection IPsec profile. Profile is prof1. Yes, prof1. isakmp is on and we are getting now EIGRP agencies. Now, if you go and check your show crypto isakmp SHA, so we have tunnel now. If you go and check your packet information, so packets are encrypting and decrypting. If you initiate your traffic, any traffic, for example, I'm trying to ping 3.3.3. Traffic is traveling and we are getting ESP protocol information. Everyone,
Yeah.
now they are communicating. Sarath, Neeraj,
Yes.
they are communicating, but now we are not getting GRE. Wait. ESP. Let's check ESP. Yes, we are getting only source public IP, destination public IP, and ESP protocol. Let's
Okay.
continue this topic in next session, everyone. Okay. Same
Okay,
time,
sir.
9 a.m. Okay,
So
Sarath.
when is next session, next week or tomorrow?
It's today is Sunday, I think. We can continue our session on next weekend
Okay, sir.
on Saturday.
Thank-
Okay.
Thank you, sir.
Bye, everyone. Take care, guys.
Bye.
Sarath, any question?
No, it is clear, sir.
Okay. I'm sharing this recording today. Okay. Wait.
Okay.
Okay.